So let's just dive right in. I think a lot of us felt, well, maybe a bit underwhelmed by GPT-5.
Yeah, I heard that too. It wasn't quite the earth-shattering leap some people were predicting. Felt more incremental.
Exactly, incremental. But, and this is where it gets really interesting, think back to GPT-4.
Okay.
Remember when it launched? It also seemed, well, just okay at first.
Right, it wasn't immediately obvious how powerful it would become.
Precisely.
Yeah.
But then over time, its capabilities just kept improving significantly.
Yeah, those underlying improvements really added up.
It just shows, doesn't it? Surface impressions, especially with AI, they can be pretty deceiving.
Absolutely. That initial reaction
Hmm.
often misses the deeper trend. We see the launch, the headlines,
Hmm.
but the real growth, the acceleration, is
Mm.
often happening, under the hood more consistently.
And that is exactly what we want to unpack in this deep dive today.
Good.
Because there's this recent analysis suggesting AI's actual growth isn't just exponential, it's super exponential.
Super exponential. That's a key term here.
It really is. So our mission really is to pull back the curtain on this idea. What does this super exponential growth actually look like? And importantly, what could it mean for you?
Okay, so to get our heads around this, we probably need to talk about a specific benchmark first.
Right, the MR benchmark.
Exactly. MR, which stands for Measuring AI's Real-World Autonomy.
Okay.
Essentially, MR tracks how long an AI can keep working on software engineering tasks autonomously and still succeed about half the time. A 50% success rate.
And why software tasks specifically?
Well, it's because software engineering is, very granular. It's token-based.
Meaning you can break it down easily?
Yeah, every step, planning, writing code, testing, debugging, it's all made of these discrete, quantifiable units like tokens or commands.
Ah, I see. So it's highly measurable.
Incredibly measurable. And that precision gives us a really verifiable window into broader abilities. Problem solving, planning, maybe even creativity, arguably. It acts as a pretty good proxy.
Okay, so MUR gives us this granular tracking of autonomous success. And the analysis of that data is what's pointing to not just exponential growth.
But super exponential.
Right. And maybe we should quickly clarify what that means. Exponential is already fast, the rate increases.
But super exponential means the acceleration itself is accelerating. The speed at which it's getting faster is also getting faster.
Wow. Okay. That's hard to intuitively grasp.
It really is. It implies a growth rate that sort of defies our normal way of thinking.
And the projections based on this model are, well, they're pretty startling.
They really are. It suggests AI capabilities are climbing much, much faster than most people might think.
Let's walk you through some specific numbers, Wen, because they really hammer home this acceleration.
Okay.
So right now, 2025, the estimate is about 30 minutes of this autonomous task time, P50 success rate.
30 minutes seems, fairly modest on the surface.
It does, but that's the baseline now. If this super exponential thing holds,
Things change very quickly.
very quickly, because just 1 year later, 2026, that number jumps to around 3 hours.
From 30 minutes to 3 hours in 1 year.
Okay. Then, fast forward again to 2027. Now we're looking at roughly 20 hours.
20 hours of autonomous work.
And then 2028, it hits approximately 176 hours.
176 hours. Let's put that in perspective.
Yeah, for you listening, that's about a month of human work, give or take.
That jump it's genuinely jarring when you lay it out like that.
Isn't it?
Going from minutes to hours, then boom, a month's worth of output.
Yeah.
In just 3 years of projection.
It shows that acceleration in action, our brains just aren't built for that kind of scaling.
Not at all.
And it keeps going. It gets even more dramatic.
Right, what's next?
2029, a massive leap to about 1,800 hours.
1,800 hours.
That's roughly equivalent to a year of human work
1 year of human-level output achieved autonomously by the AI.
in that time frame. And then 2030,
Uh-oh.
it's a truly staggering number, around 24,000 hours.
24,000.
Yeah. And the source we looked at suggests this could translate to, well, Einstein-level breakthroughs
Achieved how quickly?
in a matter of weeks.
Weeks. Wow. Okay, so think about that kind of cognitive power.
Right.
It means the usual bottlenecks in science or complex problem solving, they just fundamentally shift.
How so?
It's no longer about human brain power being this scarce resource,
Yeah.
The limiting factor isn't generating the ideas.
It's something else.
It becomes more about how quickly we can process, validate, and maybe apply that sheer volume of intellectual output.
That makes sense. And the projection doesn't stop there, does it? What about 2035?
Yeah, by 2035,
Yeah.
the model projects hundreds of billions of hours,
Hundreds of billions.
a scale that the source basically describes as, well, beyond human comprehension.
It just makes you pause, doesn't it? Trying to even visualize that kind of number, that kind of output.
You really can't. Not in any meaningful way. It forces a complete rethink of what productivity or cognitive work even means.
Okay, so let's bring it back down to earth a bit. What does this all mean for us, like, right now or in the near future? What's the immediate so what here?
I think the immediate so what is this idea, this impending reality of cognitive hyperabundance.
Cognitive hyperabundance. Explain that a bit.
Imagine a world where intellectual capital, new ideas, complex solutions, maybe even entire scientific theories, isn't scarce anymore. It can be generated almost on demand, almost without limit.
So thinking itself isn't the bottleneck.
Exactly. Cognition stops being the main constraint on productivity. AI could potentially outproduce human intellectual work by orders of magnitude.
Leading to just an explosion of new knowledge and solutions.
An era where intellectual capital is generated at a rate we've just never seen before. That's the core implication.
That is a profound shift. So let's dig into those implications a bit more. Science, for example. You mentioned Einstein-level breakthroughs by 2030.
Right, with that projected 24,000 hours of cognitive work capability.
What could that actually enable?
Well, it could mean AI generating entirely new fundamental theories. Things on the scale of relativity, perhaps.
Generated in days, minutes.
Potentially, yes.
Yes.
According to the projection. Think about fields like physics, biology, medicine.
They could be completely transformed.
Absolutely. Breakthroughs that might take human teams decades, maybe even centuries, could potentially happen much, much faster. It just changes the whole timeline of scientific discovery.
It's an amazing, almost overwhelming vision. But are there checks and balances? Or does AI just solve everything instantly because the thinking part is so fast? Practical limitations.
That's a really important point. Practical limitations, yes, there are.
Okay.
While the cognitive side, the thinking, might accelerate incredibly fast, the real world still takes time.
What do you mean? Like experiments?
Exactly. Real-world feedback loops. You need to run physical experiments to test a new theory. You need to gather data out in the world.
Build things.
Build prototypes, manufacture things like advanced chips. These physical processes, these interactions with reality, they still operate on their own timescales.
So the AI might think of a cure for a disease incredibly fast.
But testing it, clinical trials, manufacturing the drug that still takes time, the bottleneck shifts from thinking to doing and validating in the physical world.
Got it. The thinking is hyper fast, but the implementation, the real world stuff, might lag behind.
Precisely. The AI's cognitive capacity isn't the limit anymore. It's the interface with reality.
Okay. Now, if these trends, these super-exponential curves, continue, the source material argues that an intelligence explosion, a singularity, seems, well, plausible, even likely.
Yes, the argument is that it looks likely within the next decade, maybe around 2032, give or take.
That soon. How do we even process that? It feels like something out of science fiction, not something potentially just a few years away.
And that's the crux of the issue, isn't it? The author really stresses this point. We humans inherently lack good intuition for exponential growth, let alone super-exponential growth.
Our brains are wired for linear thinking, step by step.
Pretty much. We expect progress to be additive, steady. So when something is not just doubling, but the rate of doubling is increasing,
Yeah.
it's profoundly counterintuitive.
So these steps that seem small now, like maybe GPT-5 feeling just incremental.
Exactly. Those seemingly small steps could be part of a curve that suddenly goes almost vertical.
Snowballing into civilization-level changes.
In potentially less than a decade, we just don't have a good mental framework for that kind of rapid acceleration. That's maybe the biggest hurdle to really internalizing what these numbers might mean.
That is the truly mind-bending part. It challenges our whole perception of time and progress.
It really does.
So maybe the final thought to leave everyone with is this. Given these incredibly rapid, non-intuitive projections, how should you start to rethink things?
Yeah, like the very nature of human work, especially intellectual work, creativity.
What does it mean when cognition, the ability to think and solve problems, is no longer a scarce resource?
What new possibilities open up for science, for society, for humanity?
When our most complex challenges, the things we struggle with for years, could potentially be tackled by AI in days, or even minutes.
A huge question to ponder.
Yeah.
What becomes possible then?